101テック始まります。今日のテーマはジェミニが科学を変えるです。私はですね、今この恐竜が今目の前にというか後ろにいるわけなんですが、Google 本社にいます。なぜかというと、Google が年に一度開催する開発者会議 Google I の取材でやってきたからです。で、今回のその Google I では、いろんなその AI の発表はあったんですけども、とりわけ結構ね、ユニークなものが Gemini for Science というものが発表されたんです。で、AI for Science ということはクロスディグでもよく出てくると思うんですけれども、AI が科学の実験を変えていく、科学のやり方を変えていくという文脈で、よく AI 研究者の今井翔太さんとそんな話をしているんですが、この Gemini を開発する Google DeepMind もこの AI for Science に、さらに本気になってきたようです。文献調査や仮説づくり、計算実験や論文支援など、いろんな科学研究の一連の流れを AI エージェントに任せてしまおうという話なんですよね。で、実は AI for Science というのは AI 自身の研究も加速します。ジェミニがジェミニを作るという未来もそう遠くはないかもしれません。で、今回はこの Gemini for Science の研究者で Google DeepMind のチーフサイエンティストプッシュミートコーリさんに話を聞きます。で、実はですね、このプッシュミートさん、以前AlphaGoの話題でオンラインでクロスディグに出てもらったことがあるんですけれども、今回はこの本社で対面の取材が実現しました。 AI が科学をどう変えるのか、ジェミニがジェミニを作る未来っていうのは本当に近いのか、ぜひ最後までご覧ください。 Thank you very much for your time.
No, it's a pleasure.
Yeah. So, you guys announced Gemini for Science at this year's I/O. Gemini has almost billion users, whether that's office workers, executives, students, or parents. But at I/O, Google announced that it incorporates Gemini into the world of scientific research. And how does that LLM like Gemini work for science? What is the biggest change Gemini can bring to scientific discovery?
Yeah, so as part of the Gemini for Science package, we have a number of tools that are powered by Gemini that we are releasing as experimental sort of tools. The first sort of tool is the idea generation sort of tool. This is powered by our agent called co-scientist. And how this sort of agent works is as a community of sub-agents which are working together to find the solution of a scientific task. And co-scientist and the idea generation tool is able to come up with novel hypotheses for this problem by scanning the literature, critiquing, bringing sort of ideas from that literature, combining those ideas, critiquing those ideas, refining them further, and doing that at a massive scale, and finally being able to sort of produce a list of hypotheses that the scientist can investigate further. The second tool that we are releasing is a discovery tool. This is a combination of two flagship projects, our Alpha Evolve agent, which has been used for discovering various results both in mathematics and computing, but also improving our problems within Google itself, from optimizing data centers to optimizing Gemini training, our chip design sort of work, and so on, and combining that with the empirical research assistant work that also came out in Nature yesterday, where we were able to show that the whole process of data analysis that goes into coming up with building new predictors for science can be automated by the use of this tool. The third thing where we have used Gemini for Science is literature insights, and this is a tool which explores the scientific literature and extracts a lot of different insights and brings them together in a way that can be consumed by the scientists for further analysis. This is again powered by our Notebook LM team, which have also been already very successfully used across the scientific community. And finally, we have released science skills to be used in anti-gravity. And this is to really power and supercharge the ability of scientists to be able to use these science agents like anti-gravity for scientific tasks. Because the science skills package has a number of science-specific submodules to be able to reason about protein structure, protein function, a number of other relevant problems for the life sciences.
Okay. I think AI for science is often discussed in fields like biology or medicine or material science, but AI research itself is one of the scientific fields, right? So do you see Gemini for science as a way to accelerate AI research itself?
Absolutely, and that is what we are seeing even within Google. So we are seeing that agents like AlphaEvolve have been able to improve Gemini training in a number of different ways. We have been able to optimize Gemini training itself, but also optimize the chips on which Gemini runs, as well as optimize our data centers itself. So that collectively is leading to an improvement in how Google is able to conduct its own AI research and move much faster.
What was the specific process to optimize all of the AI development process?
Okay, so let's start with chip design, for instance. So one of the key projects is how do you make sure that the layout in the chips can be structured in a way so that you can have the most number of operations, useful operations done. And there are different layout schemes. What AlphaEvolve was able to do is figure out different constructions that were much more efficient in terms of the number of units required for processing those computations, leading to much better and more effective chips. The second way in which we were able to use AlphaEvolve was in the Gemini training. So one of the key things that, as you would know, is you would want to compute gradients when you are optimizing or when you are doing training of a neural network, and that requires a lot of computations. So how do we speed up that process, or how do we make that process much more efficient with the use of AlphaEvolve?
If AI starts accelerating the research by itself, how do you make sure safety and performance progress at the same pace as capabilities? How do you balance them?
At the moment, what we are seeing is these tools acting as an amplifier to human scientists. They are not working autonomously on their own and figuring out what to do. They are working in tandem with human scientists who are specifying what is the problem that requires the solution. What these agents are able to do is work on the how part. How do you solve the problem? And really accelerate that part of the problem rather than coming up with their own goals and executing them.
Google DeepMind CEO Demis Hassabis, he was at keynote yesterday, and he has often described AI as the ultimate tool for advancing science. So how does Gemini for Science fit into those long-term vision, and what do you talk about with Demis on this front?
So Gemini is our flagship and frontier foundational model, which is powering many of our agents, from agents for mathematics, for science, for many other tasks. As we see this whole work make progress, we will see a dramatic increase in the effectiveness of these tools in accelerating science. So the current generation of Gemini is extremely useful, as we have shown, as part of these different case studies, whether it's co-scientist, whether it's AlphaEvolve, whether it's the empirical research assistant. We have shown how Gemini can meaningfully not only accelerate the scientific process, but also come up with novel ideas, much like what happened at the start of this whole revolution when we were playing that legendary Go match with Lee Sedol, and AlphaGo made that move 37. We are essentially living in the backdrop of that moment, and seeing the same moment now repeat itself across multiple scientific domains.
Okay. And how does, what do you expect about how scientific research accelerates with Gemini for Science, especially in terms of automation?
Yeah. So the scientific process, if you can think of, can be categorized into 3 different stages. The first stage is specifying what is the problem that you're looking at, or what is the phenomena that you want to understand or study. The second part is how do you go about it? If you want to solve the problem, what is a good way to approach that problem? What is a good solution that we should try? And then the final part is basically validating that the solution that came up is the right solution and actually works in the real world. So the role of what is the problem is, at the moment and for a meaningful amount of time, is the task of the human scientist. The human scientist specifies what is it that we are interested in solving. What Gemini for Science accelerates is the how part. It's able to do the data analysis, it's able to gather the insights from the literature, it's able to work on the basis of those insights to come up with novel ideas that could be promising to explore for solving the problem at hand. And then there's a final part, which is validation. That final part of validation is extremely important, because we need to see whether those ideas do work in the real world. And so this is where human scientists will play a key role. First, in terms of actually validating some of those results, but as we connect these agents with automated labs, which we are also working on, then there will be, even that part will become accelerated, and the role of the human scientist will be to see whether the final results match the expectations that we went into the project with.
And how does Gemini work if we try to find new material or a new drug? How does Gemini for Science work in those situations?
So Gemini for Science, if you think about the inspiration that it takes, it gets that information and inspiration from various different sources. One source is, of course, the literature. Now, a human scientist has a limited capacity to absorb scientific literature. And a human scientist can be an expert in one domain, but cannot be an expert in all domains. But unlike the human scientist, a Gemini can read hundreds of thousands, if not millions of papers. It can be an expert in many different areas of science and might know what is happening across multiple disciplines, and use that information to bring together ideas to find the solution of the problem that is being discussed. And that is the role that Gemini can play in really pushing ideas further and the solution of these problems further.
Okay, this is the last question. As AI advances, what's the most important role for human scientists?
I think the most important role is there are two roles. I would say one is to understand the strengths and limitations of these systems, because these systems will be useful, but they will only be useful if people understand how to use them effectively and understand both their strengths as well as its weaknesses. Otherwise, we will be either either we will not leverage their strengths properly, or we might be too conservative. And both things are harmful. So the way to effectively use these tools is basically to have access to these tools, to try these tools, and to really invest in education on the understanding of these co-scientists and these and Gemini for science more broadly. The other role that I think scientists will play is that as the how part of the scientific process gets accelerated, scientists will have more time to focus on the what part, to really think about what are the problems that society needs them to solve. And instead of solving one, you can now sort of spend more time on exploring a lot more scientific problems, and to really leverage that additional capacity to see what is it that society really cares about and what are the problems, whether it's energy security, whether it's pandemic preparedness, whether it's dealing with climate change. We need to see what are the problems that people care about, and for the specific instantiation of the problem, right? If you are developing a new disease resistant species of a particular crop, you also need to consider where that crop needs to grow. The climate in sort of Singapore would be different from the climate in England versus would be different from the climate in sort of India or Africa and so on. So localization, understanding the specification of the problem at hand is extremely going to be more important.
Okay, great. Thank you for your time. Thank you very much.
Thank you.